Okay. Electromagnetic radiation in the form of infrared radiation. Okay? So what we're going to talk about right now is this thing called the greenhouse effect. The greenhouse effect is a phenomenon of energy in one form, that is, energy in the form of electromagnetic radiation, that is the sun, sunlight. Okay? And the fact that electromagnetic radiation can pass through almost unimpeded through a translucent medium. Okay? So if this is glass, and this is sunlight or a heat lamp or something, what you will find is that it can go through the glass. Light goes right through glass, right? Doesn't stop it. Okay. What happens when that sunlight hits this surface? So what happens when it hits all of that surface? No, not that one. Sorry. I screwed up. Ah. Okay, so what are the two forms of heat energy that we discussed? So somebody clearly say it. No, the forms of heat energy are not conductor. Radiation. What was the other one? Molecular excitement, for God's sake, can you guys not remember this stuff? Molecular vibration, okay? So that's it, that was the two ways. So you know what, you guys are going to get a midterm in this class. How many of you have thoroughly gone back and reviewed all of the videos and gone through all of the PowerPoints to really learn it? Well, obviously, not a lot of you, if you don't remember the two forms that heat can come in as. So, yeah, radiation and molecular excitement. That was discussed over in that room. Okay? Okay, what kind of heat is this? This is radiation. Okay. So what kind of heat is here? Molecular excitement. Okay. How would molecular excited heat get back out of this box? What form of heat transfer mechanism is there? Nope. It will. There'll be a little bit of radiation because everything radiates, but nope, that's not the primary means. First of all, it's going to conduct through this material to a point, right? So this is one molecule next to another molecule, next to another molecule, next to another molecule, next to another one. Okay? So it's going to do some level of conductance in here. Not conductance, I'm sorry. It's going to conduct through, okay, and create more molecular excitement. So convection, conduction, radiation, right? Now, what's going to happen to the air around these surfaces? It's going to get warmer. So now the air gets warmer. What happens in fluids and gases when you have a differential in temperature? What happens? The hot air moves. So all of this hot air here is going to start to flow upwards, right? And then somewhere, so let's say that it starts to create a convective current that does this. don't know that that would be the conductive current, but let's just hypothetically say that it is. So now we've got conductance occurring here, right? And we've got convection occurring here. We've got radiation occurring here. But can the conducted heat get out as fast as the radiant heat passes through the glass? No. That's why your house is warm, right? Because the heat, even though the glass is not a great insulator, it's better than an open hole in the wall. And so all of this heat energy comes through really fast, right? But it turns into molecular excitement, and it can't get back out. Because in order for it to get back out, all of this stuff has to convect enough and rub up against the glass and then conduct across the glass in order to get back out of the box. Or it's going to have to get all the way through the wall and get out the other side. So it's literally coming in at an exponential rate compared to what it can get out as. That is the greenhouse effect. If you guys take your car, right, and you come to school on a summer day and the air conditioner's on, right? So air conditioner's on and it's nice and cool in your car, and you park the car on a 95-degree day out in the sun, right? You're going to have conduction occurring through the solid surfaces, even though there's insulation. But your windows, man, when that sun beats through onto your dash, that sun is going to be barreling through at a very fast rate, and then the heat can't get back out. So you experience the greenhouse effect in your cars on a summer day all the time, right? This room on a summer day, we have so much glass all the way around it that this room on a summer day gets really hot. And the cheapskates down the hill don't want to turn the air on, so it gets really, really hot. Okay, and that's because the sun's barreling in here. They thought, oh, we've got an eve. Yeah, well, that's great. It doesn't help in August when the eve is no longer helping because it's now several months after the day it was designed for. We'll talk about more on that. So this is the greenhouse effect, okay? And this is another key thing that you guys have to understand. Now, in an ideal world, we would have lots of experiments set up so that you guys can experience these things and write a lab report on them. Because the more you write about something and the more that you physically experience it, the better chance you have of being able to recall it. Obviously, most of you couldn't answer the question about radiation and molecular vibration or molecular excitement when I asked it. So that wasn't kind of coming up as a piece of knowledge that you have internalized. So it's really, really important that you guys actually go back and study this stuff and don't just kind of assume, ah, it was interesting. He entertained me. Okay? All right, how many minutes are we at? All right, go ahead and stop it.